Okay. So, again, when we sum these equations at the end to get our final reaction, what do I do with my k's? I multiply, exactly. And if you get on your exam, you've added them in the past when we're dealing with Hess's law and enthalpy. Now this is different, so don't get those two mixed up. Remember, it's multiply. That's very good. The way that he went through it was really good. Okay, this problem we actually did today. I don't know, raise your hands if you finished your worksheet that was passed out in class today. So most of you, probably a little over half. Okay, if you haven't, great. We're going to do this problem or talk about how to do it. We have to go here pretty soon. We're going to talk about how to do it, why it's a good problem, what's important about it, common mistakes, let you do it. Those of you who have already done it, you've probably looked at the key, so you know that you did it right. If you haven't looked at the key yet, let's see if you did this. What makes this problem hard? He says you got to go backwards. Well, let's see. That's probably true. We're given this reaction, okay? We kind of already have it set up in your rice table ready to roll. You're given this reaction. You're given your K value, 110. It tells us that equal amounts of reactants are put into an with no initial product, are put into a container. There's no product in there and only reactants. So right off the bat, this brings me to a good point. When we're reading these problems, sometimes that's the hardest part, is to understand what the heck did they just ask, or what the heck actually happened, or what were my initial conditions, what was actually there. That's something I would ask myself when I do an ice table or an equilibrium problem every time. What did I start out with? How did this start? Was there product already there? What was the concentration of all these things at the beginning? So don't blow through the reading of the paragraph that's explaining the problem because you initially recognize it's going to be an ice table. But read it through. It might be tricky. Something like this. This one particularly told us that we started off with the same two reactants. We reacted, and it formed our product. And they told us at equilibrium, this is how much product we had, 0.207. Okay, and now the question wants to know what were my concentrations initially for my reactant. So not at equilibrium, but initially. So chalk. What do we need to do here? Who knows? What would you do? What's the next step someone would take? Go ahead.
I'd add 0 to 2HI.
Right up here?
Yeah.
Okay, perfect. He said, all right, I'm just going to put in what I know. And I knew that this started at 0. Do I know this? So let's give it a variable, right? Can we call it x? Sure, you can call it whatever you want. So let's call it x. I initially started off with some amounts. Are they both x?
Yes.
They are both x because they told me it's the same. So we've made it a little ways here. Now, what else would I do? What's my next step here? Just go ahead and jump.
You fill in this middle column.
Okay, let's fill in my middle column. Starting off with this. This is what I know the most about. Started off with none. How much did I add? 2x. Right? And I ended up with this at the very end. Okay? So let's stop right here. This is a very pivotal part of solving this problem. I know the way this ice table is set up that 2x is equal to this. Okay? These two are equal to one another. I started off with no products, right? I was going to add 2x amount to get what this number is. And it's 2x, again, because of the coefficient right there in my balanced reactant. Okay, so 2x equals 0.207, right? And once I do that, I'm going to know what x equals. Is it the same as this x? No. Okay, that's not. So let's do xi for x initial. Okay, this x is what we normally use, and that is our the amount that was taken away or added during the reaction to reach equilibrium. Okay, so I know we kind of have to go. I'm just gonna write out kind of the rest of how you would solve this, and let you guys, because it's on your worksheet. Okay, let you go and solve this, and then we'll stop the video and we'll do individual questions. Okay, so down here, right? I know that whatever at equilibrium my reactant's going to be is going to be this xi initial, right? Minus the number, this x that I solved for. Does everybody understand why it's that? Right? Okay, because this was minus x, right? This is xi. They are different. You can call them y and x if it makes it very clear. I want to make that very clear. They are not the same. So this would be xi minus the number that I really can solve for. It's right here. Okay? And I haven't done it, so I'm not sure exactly which one it is. This would be the exact same thing. Xi minus the number that I knew. Okay, that I solved for right here. So then the rest is just what you've seen before. You plug it into your equilibrium expression. Right? You know your K. You're going to have 110 is equal to products over reactants. So this brings up kind of another one of those opportunities where you would stop, you would look up at the ceiling or at the wall of the testing center and say, what is a common mistake that students make, or I've made, or I notice people make on ice tables? And what would be a common mistake for this one? We knew it was hard and different. What are the common ones? Regardless if we're going backwards or forward, what is a common mistake? She said products over reactants. Common mistake, even though we've heard it so many times. Common mistake. So remember, you would think that, okay, products over reactants, did I do that? Yes. Right here. Not putting it raised to its coefficient is one of the biggest one, I think. So when I do this equilibrium expression, I should get K is equal to my products here, which are 0.207. Am I done? I square it because there's a 2 here. A lot of times we forget because we think we already incorporated our coefficient in this part, but there's another spot where we put it. Right? I square it right here over my reactants here. So xi minus the number that I know, and that would be squared because they're the same, and I multiply them together. Okay? So that is everything that we have prepared, and we're going to stop the video, and we can do individual questions. Okay? Thanks, guys, and good luck on your exam.